All right, hello. This is going to be the first lesson for the second semester on first and second derivative tests. And I'm trying a new setup here, so I'm going to be looking around everywhere, but you'll also be able to see me, so that's good. The first derivative test is something that we talked about last semester, but we've got here again. So we're very sure of how to use it and what it does. The first derivative is going to help us figure out where the function has extrema. So that means max and mins. For this, if f prime of x is positive, f of x is going to be increasing. Oops. And if f prime of x is negative, it's going to be decreasing. So our extrema are going to, the max and mins, that is, they're going to help us figure out how to split up our intervals on whether or not something is increasing or decreasing. The second derivative test is going to describe where the function has points of inflection. Oh. Inflection, there we go. Or in other words, this is a change in concavity. Which is what a point of inflection, that's where there's a change in concavity. So if f double prime is positive, that's the second derivative, then the original function, remember all this is from the perspective of the original function. The original function is going to be concave, and I'll spell it out, concave up, like a cup, so CC up, and this might all be floating back to you, concave down, if the second derivative is negative. Right. So how do we use these things is the trick, and I didn't realize my head's in the way there, so let's scooch that. The thing we're going to look at for kind of to help serve as anchor points are going to be these x values where f prime of x is 0 or f prime of x is undefined. And these are called critical points. And I have a little reminder here to me that you want to put on your paper as well. Well, first we're going to label those critical points C, but these are also, so f prime of x is undefined when we have an endpoint of the interval. So for example, these next few functions that we're going to look at, so for number 1, that quadratic there is only defined on 0 to 2. So it's like we're going to have just a little snippet of it. And you know from how we define a derivative that we use limits. And you can't take the limit at an endpoint. So that's why we've got a derivative that's undefined, because we can't find a slope at an endpoint. So we are going to determine the critical points for all these things and state if the x intervals where the function is, or state where the x intervals are increasing and decreasing on that given interval. So we've got a quadratic to start off with, and first thing we're going to do when we work through these problems is we're going to set f prime of x equal to whatever the derivative is of this function. So I'm going to have 8x minus 4, and then based on the first derivative test, we're going to set this equal to 0. So 0 is equal to 8x minus 4. So that means x is equal to -1/2. And that's our first critical point. Our first critical point is it's not a coordinate pair, it's just an x value. So x equals -1/2 is my critical point. And then I've got x equals 0 and x equals 2 as my other critical points. Because, whoops, these are endpoints. So f prime of x is undefined here because those are my endpoints. So that means all of these, which we'll label, all of these are C, the critical points. So we can only find one where the function is equal to 0. That's fine. But what we're going to do now is we have to determine where the function is increasing and decreasing. So I'm going to take a number line approach to this, and I'm going to draw up my interval. So 0 to 2, and then I've got 1/2 in here. The number line is going to help me visualize what's going on with these intervals. So I want to know where these functions are increasing and decreasing. Now, I could go through the idea, I could graph this function, but I'm going to show you how to, and it's going to circle, sorry, it's a little delayed, but it's going to circle, I'm going to circle this function here. I could graph that function and we could figure that out. But we're going to use the idea of the first derivative to figure that out. So f prime of x is equal to 8x minus 4. So where is 8x minus 4? Like if we choose numbers like 1/4 in between that first interval 0 and 1/2, and then we choose like 1, if we plug in 1/4 to f prime of x, is that going to be positive or negative? It's going to show up here. If we plug in 1 to f prime of x, is that going to be positive or negative? The answer we get for f prime of x of 1/4 is going to be negative, because we're going to have a 2 minus 4, that's negative. If we plug in 1, we get a positive. We have 8 minus 4, that's positive. So this is how we would test to see if a function is increasing or decreasing without a calculator. So that means we're going to turn around and say that from 0 to 1/2, our function is decreasing. You can put a negative here if you want to, and positive over here. But we've got the data all listed right there. 0 to 1/2, we're decreasing, and then from 1/2 to 2, which we're not using brackets because that means it's included, we're increasing. Okay, so I'm going to do a couple more here, and then I'm going to set you all off on, well, I'm going to show you what number 4 is like, and then I'm going to set you all off on these problems here. For number 2, we're going to start this off the same way. We're just finding critical points and then where this function is increasing or decreasing. So on number 2, f prime of x is going to have to be done with the, let me scroll, is going to have to be done with the quotient rule. So we could rewrite this one so we could use the product rule and move like everything in the denominator up to the numerator, but we'd still have to use the product rule. And in my mind, the product rule is just as complicated as the quotient rule. So we're just going to go straight into the quotient rule. So low d high, you'll see it pop up soon, minus high d low. And that's all over low low. All right, so this looks pretty complicated, especially compared to what we just did when we set this equal to 0. But we don't want to set it equal to 0 as is because it's too much. We want to simplify the numerator sum. So I'm going to have x squared plus 2 minus 2x squared. And that's all over x squared plus 2 squared. And I can simplify the numerator a little bit, so I'm going to make this a negative x squared plus 2 in my numerator, just combining like terms. And now I can set this equal to 0. So I'm going to set 0 equal to negative x squared plus 2 over x squared plus 2 squared. Now, this still looks really complicated, but we don't have to be afraid of this denominator, which is honestly the most scary part, because that denominator, x squared plus 2 squared, when we, and I know I crossed through it, but when we solve for x here, and we've set it equal to 0, after setting it equal to 0, then we multiply the denominator over to the 0, and then it just becomes 0, it all goes away. So that's because I multiplied everything by x squared plus 2 over, or x squared plus 2 squared. Man, there's a lot of 2's. All right, so we are solving for this 0 because we want to know what the critical points are. So I'm going to subtract 2 from this side, divide by negative 1, and then take the plus or minus square root. Okay, so if you're not sure, so we've got what looks like 2 critical points here, and we also have the endpoints to consider because that's part of the critical points. So we've got negative 1, 4. So all these are critical points. C. So this has already got a little bit more flair to it, but let's check out the interval that we'll be working on. So we've got negative 1, 4, and then now we have to decide where does our, there's 0, put that in there, where does positive or negative radical 2 fit into the mix? So we already know that positive radical 1 is 1, so that must mean that negative radical 1 is greater than negative radical 2. So that means it's outside, negative radical 2 is outside our interval. So we no longer have that to consider. So we just have positive radical 2 in our interval, which, so I'll put 1 right here, which is not part of our interval. And radical 2 is somewhere just outside of 1. We don't really need to know the exact value. If you want to figure out the exact value, you can, but I'll label 0 green as well because it's not part of our critical numbers. But we only have 2 intervals, negative 1 to radical 2 and radical 2 to 4. So our test for these with these critical numbers is going to go like this. We'll choose 0. So what's f prime of 0? Is that going to be positive or negative? And then we know that 2 is somewhere in here. Radical 2 is not equal to 2, so we know it's less than that. And f prime of 2, is that going to be positive or negative? So we'll check that by putting, let's see, we're going to use this equation right here. So we'll have negative 0 plus 2 over x squared, 0 squared plus 2, so 4. So we've got a positive number. Negative 0 is just 0, so this is positive. So we'll see if f prime of 2 is positive or negative. And so we'll do negative 4 plus 2 over 4 plus 2 squared. Now, I'm not going to actually multiply this out. It would be pretty easy to do that, but I can see that the numerator is going to be negative and my denominator is going to be positive, so this is going to be negative. All right, so that means from negative 1 to radical 2, this function is positive. So the slope is positive, so we're increasing. And from radical 2 to 4, this function is decreasing. All right, so that's a pretty complicated equation there, but we were able to just use the same logic there. Now we're going to try 3. I'm going to try setting that up, and then we'll have you finish it for practice.